Hi all. In this session, we will see the DC motors, the task developed and the problems on it. Okay. So this is E. Manjula, a lecturer in EEE, working for Government Polytechnic Secunderabad. So we'll see the recap. In the previous session, we have seen that the problems on the back EMF. So now we will see the torque equation of a DC motor and the power. They developed the formulas for armature torque, shaft torque and loss torque, and the problems on the torque and speed. Okay, torque. So torque is a turning or a twisting movement of a force about an axis. Torque is a product of the force and radius at which the force acts. So let's take a pulley of radius small r meters acting upon a circumferential force of F, which causes it to rotate at n speed. So torque is equals to force into radius, which is newtons and a meter. The work done by this force in one revolution, force into distance, F, the distance is circumference, so it is 2 pi r. So F into 2 pi r joules. In the torque, work done per second is equals to force into 2 pi r into n, which is joules per second. The mechanical power developed, which is equals to F into R into 2 pi n by 60 watts. So 2 pi n by 60 is equals to omega. Omega is equals to the angular velocity in radians per second. Only omega. Okay. Omega is equals to angular velocity in radians per second, and F into R, which is equals to torque, which is equals to T. So the power developed P is equals to T torque into tau, that is angular velocity. So torque T into omega is nothing but 2 pi n by 60. So 2 pi n into T by 60 is the power developed, which is in watts. So the armature torque equation of a DC motor is, let TA be the torque in Newton meter developed by the armature of a DC motor running at n RPS. Then the mechanical power developed, which is equals to TA armature torque into 2 pi n by 60. And the electrical equation of mechanical power developed by the armature is equals to EB into IA. So this is equivalent to, in electrical, EB into IA. So from the equation 1 and 2, we can equate it because both are equal. This is a mechanical power, this is an electrical equivalent. So TA into 2 pi n by 60 is equals to EB into IA. So by substituting of EB, which is equals to pi into Zn P by 60A, we know this formula. So we are substituting this in this equation 3. Okay, then we will get TA into 2 pi n by 60, which is equals to pi Zn P by A into IA 60. So this IA will come here. So this and will cancel. This 60 will get cancelled. So TA is equals to 1 into pi z. This is 1 by 2 pi. Okay. So 1 by 2 pi into pi z IA P by A Newton meter. So this 1 by 2 pi is nothing but 0.159. So torque armature at torque at armature TA is equals to 0.5159 pi ZIA into P by A Newton meter. So shaft torque TSH. So the torque which is available at the motor shaft for doing useful work is known as shaft torque TSH. So the mechanical power at a shaft, that is the motor output power, is equals to TSH into 2 pi n by 60. So the motor output is equals to British horsepower into 735.5. So equating 1 and 2, this and this equation, so we will get TSH is equals to British horsepower into 735.5 into 60 by 2 pi n. So what is the torque loss? The torque which is lost, the gross torque or armature torque developed by the armature is not available for doing useful work, that is at shaft. So a certain So the lost torque, the gross torque or the armature torque developed by the armature is not available for doing useful work. So a certain percentage of armature torque is required for supplying iron and frictional losses in the motor. So the differences of armature torque and the shaft torque is known as the lost torque or the torque which is lost. So lost torque or lost torque is due to iron and frictional losses of the motor. So the lost torque or the lost torque is equals to, that is TL is equals to IA minus ISH. So this is about the torque, and now we will see. Okay. Now we'll see the speed equation of a DC motor, sorry. So the back EMF equation of a DC motor EB is equals to V minus IARA. We know this already. And we also know that EB is equals to pi ZNP by 68. So from both the equations, equate it because both are the same. So here, from here, N is equals to V minus and N by pi. Sorry, N is equals to, here N we are taking it out. Okay. So N is equals to V minus IA RA into 60 into A divided by pi into ZP. So this is all a numerator part. From here, this is a denominator part. So we know this is EB. So I'm directly writing it as EB. So EB into 60A by pi into ZP. So EB where K is a constant which is equals to 60A by ZP. Okay. So this total part is, we are treating it as constant because once the motor is designed, the armature, the number of armature parts will be constant, the number of the conductors will be constant, and the number of the poles are constant. Hence, we are treating all this part as constant. That we are putting as a taking a constant K. So N is equals to K into EB by pi. Okay. So here, so, yeah. N is equals to constant K EB by pi, that is flux. Okay, so from that EB, so N is directly proportional to EB and pi. Okay, this is an actual equation. So the speed of a DC motor is directly proportional to the back EMF. So from here we can say that EB is directly proportional to back EMF. Okay. If, example, even this pi is constant, then speed is directly proportional to EB. Yes. So the speed of a DC motor is inversely proportional to the magnetic flux per pole. One second. So here the equation is EB is equals to pi into n. So n is inversely proportional to pi 1. This equation, see here it is pi is there. Sorry, I have not noticed. Divided by pi. Yes. Because EB is equals to, because EB is equals to pi z then P by 60A. So from that equation, we can directly tell that if we take n out, n is directly proportional to EB but inversely proportional to pi. So from this equation, the speed of the DC motor, any DC motor is directly proportional to the back EMF, and the speed of a DC motor is inversely proportional to the flux per pole. Okay. So here, speed equations of a DC motor, let the initial values of the speed, the armature currents and the back EMFs and the flux per pole of a DC motors are N1, IA1, EB1 and Pi1 respectively. Okay. And the corresponding final values of the speed, armature, current, back EMF and flux per pole of a DC motor are N2, IA2, EB2 and Pi2 respectively. So here N1 is directly proportional to EB1 by pi1, where EB1 is equals to V minus IA1 RA, and N2 is directly proportional to EB2 by pi2, where EB2 is equals to V minus IA2 RA. Okay, so this is about the uh, equations of the speed for series, for a series motor, prior to the saturation of the poles. Okay, so there will be a point called saturation of poles, beyond which though we excite the fields, the current in it does not change, hence the flux also do not changes. Okay, so here pi is directly proportional to ISC and ISC is directly proportional to the armature current. As it is a series motor, the flux is directly proportional to the field current, that is ISC, and this field current is directly proportional to IA because these are IA and ISC are in series. Okay, so here N1 by N2 is equals to EB2 by EB1 into IA1 by IA2. So instead of flux, what I am taking directly the IA current for series motor. So see here, For shunt motor, the flux will be constant. Say that is V by RSH, V will be constant and RSH will be constant. So pi SH, ISH also will be constant. But in series, always this flux will be changing as IA will be changing, ISC will be changing. So flux will be changing. So this flux is directly proportional to the IA, armature current. So here N2 by N1 is equals to EB2 by EB1 into, instead of flux, I am taking directly IA1 by IA2. So for shunt motor, the flux practically remains constant. That is what I said before, that pi1 is equals to pi2. Hence N2 by N1 is equals to EB2 by EB1. Okay. But whereas in series, how we got N2 by N1 is equals to EB2 by EB1 into IA1 by IA2, because the flux is depending upon the current. Okay, fine. So we will see some problems on the torque. So here, a DC motor takes an armature current of 110 amps at 480 volts, and the armature circuit resistance is 0.2 ohms, and the machine has 6 poles and the armature is lap connected with 864 conductors, and the flux per pole is 0.05 webers. Now calculate the speed and the gross torque developed by the armature. So before going to solution, first of all, any problem need to be understand. You should analyze. So here it is a DC motor and armature IA is equals to 110 amps, V is equals to 480 volts, RA is equal to 0.2 ohms, and P is equals to 6, Z is equals to 864, and flux per pole is 0.05 webers. Now we have to calculate N and gross torque TSH. Okay. So the solution, given data is IA is equals to 110 amps, P is equals to A is equals to 6 poles, and V is 480, that is 864, A is 0.2, and pi is equals to 0.05 webers. So we know that EB is equals to V minus IARA, which is equals to 480 minus 110 into 0.2, which is equals to 458 volts. And EB is equals to pi z and P by 60A. So here pi is 0.05 into 864 conductors into speed we don't know, we have to find out, into 6, that is the number of poles, 60 into 6 number of parallel paths. Okay, so after calculating this we will get N is equals to 636 rpm. Here EB we have to substitute that, EB is equals to 458. So substitute 458 here in place of EB. Then we will get N is equals to 636 rpm. Okay. Now torque. So we know already the torque equation also. The torque TA is equals to 0.159 pi Z IA into P by A. So we know pi, we know Z. Okay. We know IA also. Now we have to calculate IA. Okay. So we have to calculate TA. Substitute all the values which are available and we will get the TA is equals to 756.3 newtons meters. Directly given RA. So now we got TA is equals to so and so. So we calculated EB, we calculated N, and we calculated TA. So gross The gross torque they have asked which is developed at the armature, that is 756.3. Okay. Now we will go for the second problem. So second problem, that it is telling that a 220 volts DC shunt motor runs at 500 rpm. It is a shunt motor. When the armature current is 50 amps, calculate the speed if the torque is doubled, given that RA is 0.2 ohms. See, now like such problems you have to put your mind and analyze the questions. Okay, because the problems which we have done before previously, that are directly can substitute in the formulas which are available, and such problems, now what we are seeing, there will be some logic here. Okay, fine. Here they are telling that when the armature current is 50 amps, calculate the speed if the torque is doubled, given the value RA is 0.2 ohms. Okay, so this is the given data. V is 220, N is 500. IA1 is 50 amps, RA is 0.2 ohms. So it is doubled, and there will be a speed change, there are torque change. So it is not stick to an initial point, so we have even final points also, that is IA2 or else something. Okay, we have to find. So here the torque is double, that is TA2 is equals to 2 into TA1. Okay. So initially when compared to the initial points, the final point is doubled the initial point. So TA2 by TA1 is equals to 2. So we know that the torque is directly proportional to pi into IA. So torque is directly proportional to pi into IA, where since pi is constant because it is a shunt motor, pi is constant. So TA is directly proportional to IA. So what happens? See, we know that the torque TA1 at IA1, that is equals to 50. Now the final torque is, so TA1 is directly proportional to IA1 and TA2 will be also directly proportional to IA2. Okay. So TA1 by TA2 is equals to TA2 by TA1 is equals to IA2 by IA1. So we know that this is 2. So IA2 is equals to 2 into 50, which is equals to 100. So the final point at where the torque is doubled, at that particular point the current also doubled. Because of the doubled the current, the torque has been doubled. Okay. So now the IA2 is 100 amps. So we need to find out EB1, the initial, with the initial points we have to find out the back EMF. So V minus IA1 is 50 into RA, that we are getting 210 volts. And when the current increased to double, that EB2 is equals to V minus IA2 RA. At that point the voltage, the back EMF is 200 volts. Okay. So we know that the speed equations uh, in the shunt field winding, in the shunt motor, we know the speed, that is N2 by N1 is equals to EB2 by EB1. As pi is constant, so the speed is directly proportional to the back EMF. So here N2 by 500, we know N1 is 500, which is equals to EB2 is 200 and EB1 is 210. So substituting the values, because we know N1, we know EB2 and we know EB1. So we can get directly N2. So the value N2 is equals to 476 rpm. Okay. So we got the speed. So this is how the logic sometime exists in the problem. So they have given the doubled the task. So what we have to find out, we found the current, because the torque is doubled means without increasing the current, here that torque cannot be doubled because every parameter is constant, so the torque is directly proportional to current. Hence, as the torque is doubled, so the current is has been doubled. Okay, so with that logic, and we have continued the problem, and we got N2. Okay, fine. We will see the another problem with a series motor here. Okay, see here, a 460 volts DC series motor runs at 500 rpm, taking a current of 40 amps. Calculate the speed and percentage change in torque if the load is reduced so that the motor is taking 30 amps. Calculate the resistance of the armature and field circuits is 0.8 ohms. Assume flux is proportional to the field current. So here the given data is Ia is equals to 40 amps, 500, N is equals to 500, and asking us to calculate the speed and percentage change in torque. So percentage change in torque means there is a change in, there are 2 points, that is initial point and final point. Okay. So percentage change in torque if the load is reduced so that the motor is taking to 30 amps. See, so initially it was 40 amps. So IL, if I can say IL is 40 amps before, and now it is 30 amps. Okay. So there are 2 points. So total resistance of the armature and field both combined means RSC plus RA is 0.8 ohms. And assume the flux is proportional to the field current. So phi is directly proportional to ISC. Okay. So the given data, before giving data, we will draw the circuit diagram so that the analyzation will be easy. Okay, this is IL and this is ISC. And this is IA. Okay, fine. So according to the given data, V is 460, IA1, which is equals to ISC1. So IA1 is equals to ISC1, which is equals to 40 amps. So RA plus RSC is 0.8 ohms. N is 500 rpm. So IA2 and ISC2 is 30 amps. Okay. So assuming the flux, that is phi is directly proportional to ISC, and we know that ISC is equals to IA. Okay. So here the torque equation, according to the torque equation, torque ITA is directly proportional to pi into IA. So whereas in a shunt the pi will be constant, here pi is not constant, it depending upon the armature current or else a series field current. Okay. So if I say the pi is directly proportional to ISC and ISC is equals to IA, so instead of ISC directly I can substitute IA. TA is directly proportional to pi into IA. Pi is directly proportional to ISC. So when I substitute here ISC, instead of ISC, I can substitute IA. Hence, torque is directly proportional to IA square. So, IA1 is directly proportional to IA1 square. TA1 is directly proportional to IA1 square, which is equals to 40 square. And TA2 is directly proportional to IA2 square, which is equals to 30 square. So TA2 by TA1 is equals to 900 by 1600, which is equals to 9 by 16. So percentage change in torque is TA1 minus TA2 by TA1 into 100. So this minus this, TA1 minus TA2 by TA1 into 100. So this part is equals to 7. So total percentage change is 43.75. Okay. So here we have got change in torque. So now we have to find out the EB1. So EB1 is equals to 460 minus 40 IA1 into 0.8 ISC plus RSC, which is equals to 428 volts. And EB2 is equals to, instead of IA40, here IA2 we have to take, that is 30. So we'll get 436 volts. So we know, because here we have to consider pi value, that is IA here. So N2 by N1 is equals to EB2 by EB1 into IA1 by IA2. So substitute the values directly. So we know I1 is equals to 500. N1 is equals to 500. So N2 directly we can substitute all the values which we already have except N2. So substitute all the values. Then we will get N2 is equals to 679 r.p.m. Okay. So here the N2 is 79 rpm. So before we have found the speed for a shunt motor, and now in this problem we found for a series motor. So these two are different motors, and how we have applied here the equations, it is very clear. Okay, and we'll see the another problem. So it is a DC series motor operating at 800 rpm with a line current of 100 amps from 230 volts main. Its armature circuit resistance 0.15 ohms and its field resistance 0.1 ohm. Find the speed at which the motor runs at a line current of 25 amps, assuming that the flux of this current is 45% of the flux at 100 amps. So here they have given another clause. So it is very important to understand the problem first before doing any solution. Okay. So here they have given a series motor and which is running at 800 rpm and the IL is 100 amps and V is 230 volts and RA is 0.15 ohms and RSC is 0.1 ohm. Find the speed, that is N, which means N2 at IL is 25 amps. Okay. Assuming that the flux at this current, means at 25 amps current, is 45% of 100 amps. Okay. So here what it is, pi 2 will be 45% of pi 1. That is the clause it has been given. Okay. Fine. Now we will write the given data. The given data, N1 is equals to 800 rpm, RA is 0.15 ohms, IA1 is equals to ISC, which is equals to 100 amps as it is a series motor. So RSC is equals to 0.1 ohms, V is 230 volts, IA2 is 25 amps. Okay, so here see what we, in this assumption, we know that pi 2 is equals to 45% of pi 1, which is equals to 0.45 pi 1. Okay. So pi 1 by pi 2 is equals to 1 by 0.45. So EB1. So we know IA1. Okay. So EB1 is equals to 230 minus 0.15 plus 0.1 into This is IL, ISA and IA. All are equal. So directly we substituted, that is 100, that is IA1 which is equals to 205 volts. Okay. So IB2 which is equals to 230 minus 0.15 plus 0.1 into 25. Now IB2 is 223.75 volts. So here N2 by N1 is equals to EB2 by EB1, which is equals to pi 1 by pi 2. Okay, so pi 1 is 1, pi 2 is 0.45. So substituting all the equations here, directly we will get the N2 value. Okay, so N2 is 1940 rpm, 1940 rpm. Okay, so here what we can analyze. See, the flux is reduced at the final point, but the current is increased. So that is what initially when we found the speed equations, that n is inversely proportional to pi. So if the flux decreases, the speed increases. That is what we can observe in this problem. Okay, fine. Now we'll go for the fifth problem. So this problem is saying that the 250 volts DC shunt motor runs at 1000 rpm while taking a current of 25 amps, and the resistance of armature and the field circuit are 0.2 ohms and 250 ohms respectively. Calculate the speed when the load current is 50 amps. If armature reaction weakens the field by 3%, determine torque in both the cases. Allow voltage drop per brush is 1 volt. Okay. So here they said that calculate the speed when the load current is 50 amps if the armature reaction weakens the field by 3 amps. Okay. Okay, fine. So here B is equals to 250 volts, RA is 0.2, N is 1000, RSH is 250, IL1 is equals to 25, IL2 is 50. So pi 1 is the flux at a line current of 25 amps. As the load current, which is equals to 50 amps, increases, armature reaction weakens pi. So pi 2 is equals to 100 minus 0.03 into pi 1. Okay. So it is weakening by 3%. So it is 0.97 pi 1. So pi 2 is weakening by 3%. So it is 97% of pi 1. Okay. So pi 2 is 97% of pi 1. So pi 2 by pi 1 is equals to I divided by 0.97. So it is just like a previous problem. So ISH is equals to V divided by RSH, that is 1 amp, and IA1 is equals to 25 minus 1 into 1, which is equals to 24 amps. As this is a shunt motor, though it is a shunt motor, the flux has been given, the variation of the flux is given, so we have to substitute the flux values also. So EB1 is equals to 250 minus 24 into 0.2 minus 2, this is a brush drop, which is equals to 243 volts. And IA2 is equals to 50 minus 1, that is line current minus shunt current, that is 49 amps. And DB2 is equals to 250 minus 49 into 0.2 minus 2, 238.2 volts. So N2 by N1 is equals to EB2 by EB1 into pi 1 by pi 2. So substitute all the values in this equation except N2, we know all the values. So directly we can substitute the all available values. That is EB2 is 238.2, EB1 is 243.2, and the pi is taking as 100%, that is 1, and pi 2 is 0.97%. So N2 we will get 1010 rpm, that is 1010 rpm. So this is, and the torque TA1 is equals to 9.55 EB1 IA1 by N1, which is equals to 9.55 into 243.2 into 24 divided by 1000. So we will get 55.7. Newton meter. So IA2 is equals to, directly we can substitute the values that are available. So TA2 is equals to 110.4 Newton meter, not RPM, Newton meter. Okay. So these are the two torques at a change. Okay. This is the initial torque and this is the final torque. So it is very much clear that we could able to understand the concepts of DC motors or the DC generators with the applicable, with the solving the problems. You will come to know what are the logics available and what are the uh, different concepts, how they are involved. Okay, fine. So we discussed about the torque equation of a DC motor, armature torque equation, shunt shaft torque equation, lost torque equation, speed torque equation, and problems on torque and as well as speed. Okay, so let we do a simple question quiz. Okay, so the speed of a DC motor is directly proportional to back EMF and flux. Directly proportional to back EMF and inversely proportional to flux. Yes, it is C. Okay, sorry, it is B. Directly proportional to back EMF and inversely proportional. So there are some of the questions which are frequently asked. So these are some of the questions. Okay, if you practice these things, it is enough, Amma. You could get able to, you can get a very good score. Okay. Hope today's session is understood to you all. Okay. Thank you. Thank you so much.